Here I have a map of the United States with some just important rivers. We have the Missouri River, the Mississippi River, the Ohio River, the Rio Grande, or the Rio Grande, and the Colorado River. Here is the Rocky Mountains and the Appalachian Mountains. What I'm trying to do is just simply show a continental divide, which is denoted with this red line. So essentially, think of that as the ultimate drainage basin. So all rivers inside this red line, all of them flow to this one particular destination, the Gulf of Mexico. So this is the largest by far. Think about of our continental divide. We think about our large drainage basins. This is by far the largest, the Mississippi slash Missouri slash, if you include the Ohio River. Over here, we have everything flowing towards the Atlantic, whether it be on this side of the Appalachian Mountains up here in New England and Canada, or on this side of the Appalachian Mountains along the entire Atlantic coast. Note that everything flows, in this case, towards the Atlantic Ocean. Way up here in North Dakota and the extreme northern part of the United States, everything here actually flows towards the Arctic Ocean on this side of the red line in this particular area. And over here in the west coast, we've got various rivers that flow towards the Pacific Ocean from the interior. There is one exception to that, and this is this area of internal drainage. So essentially, there are no rivers that lead to an ocean. All the rivers and everything flows internally. And so this is where we're also going to find the Great Salt Lake. And so the reason why it's so salty is essentially all that sediment, all of that salt has been carried to a particular lake and it essentially has been left there. Whereas, we think about that happening on the long coastlines, dumped into an ocean. So over time, what happens is evaporation accelerates because of, think of it being super dry. And so what happens is all that's left behind is the water essentially evaporates. All that's left behind is the sediment, sand, but a lot of salt. That's why it's so salty, the Great Salt Lake. So what we've done here is essentially looked at the continental divide, looked at different areas in which we see rivers, what direction they're flowing from the most broadest level, and also identified an area of internal drainage. Right here is the good state of Indiana, where we have flowing right through it, of course, the Ohio River, but on the northern part, the northern, think of it, northern fourth, actually has a continental divide going right through it, but not a lot of people know about it. This continental divide we can actually show here on this particular map in this red line. So all the rivers on this side or the south side of that particular red line, which denotes the continental divide, flow towards the Gulf of Mexico. The Kankakee River and the Maumee River don't flow towards the Gulf of Mexico. In that case, they flow towards the Great Lakes and eventually towards the Atlantic Ocean via the St. Lawrence Seaway. So here in Indiana, we've got a continental divide. So if you're from Fort Wayne, you live right there in the middle of the continental divide. And I wonder if it's shown on a map somewhere or shown somewhere on a highway. I think it should be. Anyway, let's focus on two important rivers. After all, that is much of the focus of this discussion. We've got two rivers in Indiana that are very important. Besides the Wabash and the Ohio, and that's the White River. But what's confusing is we have the White River West Fork and the White River East Fork. Such a bad name because they're two completely different rivers. Why are they called this? And so just think about back in the day, whenever whoever named this particular river, they got to this point and they said, "Oh, this is the White River. Up, it goes to the west. Up, it goes to the east." As they came through and explored this general direction, these rivers are completely different. One has one origin and flows through some industrial cities, goes through some very populous cities, including Indianapolis, whereas the other one typically goes through more agricultural areas, more rural. In this particular area of Indiana, further, it's essentially the White River. East Fork starts right there, so it starts at the confluence of three different rivers, where the other one starts as one, and it goes through, like I said, very lightly populated, very forest land area through here. This is much different than what you would find up here, where it's very ag, very industrial. Think of Anderson. Think of Muncie, being two cities located along the West Fork of the White River. Here's the origin of the West Fork in some guy's farm field over there in east central Indiana. Here's the origins of the East Fork at the confluence of the Driftwood River, along with the Big Blue River, along with the Flat Rock River, come together here in Columbus, and that's the East Fork of the White River. Let's focus in on one particular area of the East Fork. So we zoom into this red box where we have the Muscatatuck River coming into contact with the East Fork of the White River. So here's the East Fork of the White River, an aerial view, and then here is the Muscatatuck, this blue line, and this is the confluence of those two different rivers. In this particular image, we can see these various landform features that I discuss throughout this particular discussion on rivers. Do we see a floodplain? Absolutely. We see a floodplain throughout. Much of this area is floodplain, but you can see it really through here. You can see this area looks like it's green, probably has been recently flooded. So you can see maybe some leftover bits of water, little pockets of water. So this entire area represents a floodplain. What about an undercut bank? This is going to be the outside of one of our meanders. So there's a meander, and so it's going to be on the outside. So another meander, the outside, we see the undercut bank. So the undercut bank on the outside. You'll notice you're not going to find a lot of vegetation along that outer edge. Meanwhile, the point bar deposit, the inside of a meander, we do see kind of a collection of sediment, in this case sediment that's over time, some little bit of some vegetation has developed along the inside of these meanders, and so the inside of these terms really can clearly see a point bar deposit right there along that inside meander. Speaking of meanders, do we see a meander scar? Once again, a meander scar is going to be kind of a U-shaped feature, and we see them all over the place. These are places in which they used to be an oxbow lake that essentially dried up. Speaking of oxbow lakes, do we see them? There's one that looks like it's full of water. I don't know. We might have an oxbow lake there. If we have water there, maybe there as well. I wonder if that's probably more of a meander scar because it's now vegetation. But that's clearly an oxbow lake. There was recently one. So you can see all these meander scars used to be oxbow lakes, essentially have just dried up.